Next, we are to verify the divisibility test for 3 using congruence. We all know this statement as we are trying to immediately answer whether an integer is divisible by 3 by this idea. An integer is divisible by 3 if and only if the sum of its digit is divisible by 3. We often teach this to our students that if we have a given number, we can automatically identify if it's divisible by 3. If we add all digits and the resulting number is divisible by 3, then automatically that integer is divisible by 3 as well. But here we're going to use the congruence to verify this divisibility test. It might take a lot of time and spaces, but of course, there are important background concepts that are already identified for us to review because we'll be using them here. To start with, let us have this proof. Okay, so we'll be proving this statement or verifying using the idea of congruence. First, let us try n. Okay, n be any integer represented with base 10. So let n be an integer with respect to base 10. And let's have that. Okay, if we have this now, we can rewrite n here, okay, is equal to a sub m times 10 to the power of m. This will be the first digit plus the second digit times 10 to the power of m minus 1 plus dot 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 plus a sub 2 times 10 squared plus a sub 1 times 10 plus a sub 0 with 10 to the power of 0, which is 1. This will be our units digit, tens digit, only the a sub a's, hundreds digit. This will be our first digit and second digit. So those are your digits of your any integer that is very large and you're trying to determine whether it's divisible by 3 or not. The next thing here, let's call this equation A because we're going to connect it to something later. Let us try to come up with the relationship since we're using here base 10 and it's easiest to use that because we could come up here this form by base 10 or even 10. We know that 10 is congruent, or we're using now congruence, 1 modulo 3. Okay, this is the congruence of 10 in modulo 3. This means that since 1 is the remainder, this means when 10 is divided by 3. That is its form. This is our remainder. Okay, when 10 is divided by 3, the remainder is 1, so you have this form here. That is what it meant. At the same time, why we use modulo 3? It's because we're testing for divisibility of 3. Okay? If we're testing divisibility of 2 in the previous video, we used modulo 2. If we're going to test for divisibility of 4, in the next video probably we'll have modulo 4. Okay? So just for the background of these steps. So with this, we'll be using this congruence as we also use here some concepts of the power law of our congruence. If we have here the congruence of 10, our 10 is congruent to 1 modulo 3. If we're going to square 10, it's just the same as squaring 2 here as well. 1 here as well. Modulo 3. This would mean that the remainder for 10 squared when divided by 3 is also 1 squared, or it's just simply 1. Modulo 3. Okay? Next, if we're going to have 10 cubed, simply 1 cube here as well. Modulo 3, which means that if we're going to cube 10, it's congruent to 1 modulo 3 as well. And of course, if we're going to increase it to a certain m, they are still congruent to 1 to the power of m modulo 3. And of course, as long as m is an integer, 10 to the power of m is just congruent to 1 modulo 3. All of these are using the power law, which is actually taken from this first identity here, or congruence rather. Let's call this B. So we have now our equation A, our relationship B, and let's go back to that. Okay, let's go back to here. Going back to a. But of course, before we proceed, hopefully you were able to understand this. Here, we just represented it in our a. We just simply represented integer n with base 10. And on the next one, for power results for our b, they were just actually the result of power law of congruence, which already identified by 10 is congruent to 1 modulo 3. Again, please make sure you were able to understand this. 1 is the remainder when we divide 3 by 10. Okay. So going back to a, this is our a earlier. A to the power a sub m times 10 to the power of m plus, okay, a m minus 1 times 10 to the power of m minus 1 plus dot 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 plus a sub 2 times 10 squared plus a sub 1 times 10 plus a sub 0 times 10 to the power of 0 is just simply equal to 1. If we are going to use here modulo 3, because we are testing for divisibility test for 3, if we're going to add here modulo 3, our n now, we no longer use equality, congruent to, okay, we'll have here a sub m 10 to the power of m plus a sub m minus 1 times 10 to the power of m minus 1 plus dot 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 plus a sub 2 10 squared plus a sub 1 times 10 plus a sub 0, and you have here your modulo 3. Okay, again, it's modulo 3 because we're testing for divisibility test of 3. When we distribute modulo 3 to all the terms, we have n is congruent to a sub m 10 to the power of m modulo 3 plus a sub m minus 1 times 10 to the power of m minus 1 times modulo 3 plus dot 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 all terms inside as well, a sub 2 10 squared modulo 3 plus a sub 1 times 10 modulo 3 plus a sub 0 modulo 3. Okay, so with that, we can now have this form here. What do you call this one? Let's try to go back to b. Okay, let me remove this first. Okay, by b, which is the set of relationships here. We know that 10 squared is congruent to 1 modulo 3. 10 cubed is congruent to 1 modulo 3. 10 to the power of m is congruent to 1 modulo 3. The same as 10 is congruent to 1 modulo 3. This means that this expression here, this expression here, this expression here, and here as well, of course we don't have that there, they are all equal to 1, which means n is congruent to a sub m times 1 plus a sub m minus 1 times 1 plus dot 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 plus a sub 2 times 1 plus a sub 1 times 1 plus a sub 0 modulo 3. Of course, you could also have your 10 to the power of 0, so you have your modulo 3 as well. Now, what do this mean? What does this mean? Take note that if we have here group a sub m, because that's just 1, m minus 1 plus dot 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 plus a sub 2 plus a sub 1, and if you're going to have a sub 0, removing our modulo 3. Now it doesn't matter if you don't have modulo 3 here because you already applied 1, because they are all under modulo 3. What do you think are these? Okay, this is now where our analysis will come in. What are these? Specifically, let's say this is C. Okay, when could we say that our C will give us divisibility of 3? That is, n is congruent to 0, because if it's divisible, I mean the remainder should be 0. N is congruent to 0 modulo 3 if and only if this entire expression a sub m plus a sub m minus 1 plus dot 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 plus a sub 2 plus a sub 1 plus a sub 0, all of this is also congruent to 0 modulo 3. Okay, this is only true if the entire expression here, this one here, is will give us a result of 0 modulo 3, because if this would be congruent to 0 modulo 3, as you substitute 0 here, you will have this form. By the way, this is a 3, by the way. Okay? So, what does it tell us? What is this? This is actually the sum of its digits, right? The sum of digits will have a remainder of 0 when divided by 3. Okay? This means, this shows that for an integer n be divisible by 3, this entire expression, okay, the sum of its digits must also have a remainder of 0 when divided by 3. And in simpler sense, it means divisible by 3. And this is actually the statement or the divisibility test for 3. An integer is divisible by 3 if and only if the sum of its digits is divisible by 3. Because if the sum is divisible by 3, we could get here 0, and we substitute here. This means that our n is divides 3 without any remainder. Okay? So we did this by starting with the expression of any integer, very large or very small, but as long as it's a positive integer, with base 10. Okay? And then we use this idea of congruence for just base 10. Using the power law, you will have 1, 1, 1 as well. Going back to the first equation, applying modulo 3, and distributing that carefully, you will have these forms, which is 1, 1, 1, 1. Okay? Once you have that 1, you can take them out. You have your modulo 3 here. And this is actually the sum of its digits. And this will only be equal to 0 if this is also congruent to 0 modulo 3. Or in other words, the sum of all digits is divisible by 3. This is how we show the validity of the divisibility test for 3 using congruence. Thank you very much for watching.